Dear students, welcome to s.mathguru classes. So, we discuss some problems about method of Lagrange multipliers of first order linear partial differential equation. So, we consider the remaining problems. Solve y minus zx into p plus x plus yz into q equal to x square plus y square. So, I recall the formula. We know if capital P small p, capital Q small q equal to r, then the auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. We know this. So here we get this is capital P, this is small p, this one capital Q, small q, this one R. Therefore, solution we write the auxiliary equations are dx by capital P, P means this one capital P, y minus zx equal to dy by q x plus yz dz by r, r means x square plus y square. We get this. This is number 1 we consider. So first we choosing some multipliers that denominator must be equal to 0. So we choosing x minus y z as multipliers. Each fraction of 1. That means we multiplying numerator and denominator by x, here minus y, here z, and adding we get x dx minus y dy plus z dz divided by this is x into y minus zx minus y x plus yz plus z x square plus y square, this. So this implies x dx y dy plus z dz by xy minus zx square minus xy minus y square z plus zx square y square z. We get this one. So we cancelling xy, zx square, these two are cancel, y square z cancel. So what we get, denominator is 0, x dx minus y dy plus z dz, and denominator is 0. If denominator is 0, then we write numerator equal to 0. Therefore, we can write x dx minus y dy plus z dz equal to 0. By rules, we write this equal to 0. Integrating both sides, we integrate both sides, y dy integration z dz equal to 0. This will be x square by 2 and this one minus y square by 2 z square by 2 equal to c1 by 2, because left hand side by 2 right hand side also write this, and this equal to x square minus y square plus z square equal to c1. We get the first solution. Next we consider again some multipliers, again choosing yx minus 1 as multipliers each fraction of 1 equal to, we multiplying, first one is y dx, next one x dy minus 1 dz. This is multiplying by y, this one x and this one minus 1, and this equal to y into y minus zx plus x into x plus yz minus 1 into x square plus y square. Get this. This will be y dx plus x dy minus dz by y square xyz x square xyz minus x square minus y square. So y square cancel, xyz x square cancel. We get denominator is 0. So what we get, y dx plus x dy minus dz by 0. Therefore, by rules we have y dx x dy minus dz equal to 0. This can be written as dxy minus dz equal to 0. We integrate both sides, dxy minus dz equal to 0, and this is integration dxy means xy minus z equal to c2 we get. So we get first solution is x square minus y square plus z square equal to c1, and next solution is xy minus z equal to c2. Again you know this, if u equal to c1, v equal to c2. If one solution u equal to c1, another solution v equal to c2, then required solution will be f of u comma v equal to 0. This is our required solution. So this is u and this one v. Therefore, the required solution is f of x square minus y square plus z square comma xy minus z equal to 0, and this is our final answer. Very easy solution, very interesting. Another problem, solve x plus 2z into p, 4zx minus y into q, 2x square plus y. So this is capital P, small p, capital Q, small q, this is R. So the auxiliary equation will be, the auxiliary equations are dx by x plus 2z, dy by 4zx minus y, and dz by 2x square plus y. This is number 1 we consider. Now choosing y x minus 2z, yx minus 2z as multipliers, each fraction of 1. We choosing these are the multipliers, each fraction of 1, y dx plus x dy minus 2z dz by y into x plus 2z x into 4zx minus y minus 2z into 2x square plus y. So we multiplying, numerator and denominator by this is yx minus 2z. What is our target? Our main aim to find denominator 0. Y dx, x dy, 2z dz. This is xy plus 2yz, 4zx square minus xy minus 4zx square minus 2yz. If we multiply all of this, we get this. So xy cancel, 2yz cancel, 4zx square cancel. So what we get? Y dx plus x dy minus 2z dz by 0. So by rules, if denominator is 0, then we get, therefore we get y dx plus x dy minus 2z dz equal to 0. We get this. Now integrate. So this can be written as dxy, because variables are different. This is y, this is dx, this is x, dy. We write in this way, 2z dz equal to 0. We integrate both sides, dxy to z dz equal to 0. This is xy to z square by 2. If we integrate, this is c1, and this implies xy minus z square equal to c1. We get the first solution. Next, again is using the multipliers. Again choosing twice x minus 1 as multipliers. Each fractions of 1 equal to, so we multiplying this one by twice x dx. So twice x dx minus 1 dy minus 1 dz. So this is twice x plus 2z minus 1 4zx minus y minus 1 2x square plus y. This one we get. So this implies twice x dx minus dy minus dz by 2x square 4zx minus 4zx plus y minus 2x square minus y. So 2x square cancel, y cancel, 4zx cancel. So what we get? Twice x dx minus dy minus dz by 0. Then by rules we have 2x dx minus dy minus dz equal to 0. If we integrate, we get this. Then this is 2x square by 2 minus y minus z equal to c2. So this implies x square minus y minus z equal to c2. So we get two solutions. First one this, and this one second. Again I recall, if the solutions are u equal to c1, v equal to c2, then the required solution equal to u, v equal to 0. U equal to c1, v equal to c2, then required solution will be u, v equal to 0, f of u, v equal to 0. So this is u equal to c1 and v equal to c2. Therefore the required solution is f of xy minus z square comma x square minus y minus z equal to 0, and this is our final answer. So I hope dear students, you are all enjoying with this type of problem. So these are very easy but most important for engineering courses, B.Tech courses. So if you are enjoying with this problem, then please share this video to your friends also. Then they also will get some interest and interesting problem. So if you are getting interest, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.